Hello students and good afternoon. So today also we will do this integration by parts, and in the last online class also we were doing this same chapter, that is integration by parts. So today is your continuation class. Okay, same exercise 7, page number 380, 4 marks section from the book Higher Mathematics for Class 12 by S.N. Day. And in the last online class we did up to 10 number 1. So let us do this 10 number 2. So I think you have understood that 3 standard integrals in integration by parts, and I told you to prove formula number 2 also. I think you have done it. Okay, so let's do this 10 number 2. So here you have to evaluate this integration, that is integral of x log of within bracket x plus root under x square plus a square bracket close dx. So let us first write down I is equal to integration of x log within bracket x plus root over x square plus a square dx. Okay, so here what is x? X is an algebraic function, that is your a, and log of x plus root under x square plus a square, that is your logarithm function, that is L. So which letter comes first in the word ilet or liet? L comes first, isn't it? So this logarithm function is the first function and this algebraic function is the second function. So let us use integration by parts in this case. So I is equal to log x plus root over x square plus a square integral sine x dx minus integral sine second bracket dy dx of what? First function, that is log of x plus root over x square plus a square. That is, you have to differentiate this first function log x plus root under x square plus a square with respect to x, and then integration of x dx second bracket closed dx. Is that understood? So now let us simplify it. I is equal to, what is integral sine x? Let us first integrate first x, integration of x is x square by 2, then log within bracket x plus root over x square plus a square minus integration of, what is dy dx of log x? It is 1 by x. So it is 1 upon x plus root over x square plus a square into, within third bracket, it is taken as log x to differentiate it. Which function is taken as x? X plus root over x square plus a square. That x plus root over x square plus a square is also to be differentiated. So what is this differentiation? For x it is 1 plus 1 upon, it is 2 root over x square plus a square into 2x. Okay, differentiation of x with respect to x is 1 plus, this is just like your root over x. What is the differentiation of root x? 1 by 2 root over x, that is x square plus a square. Here also x square plus a square is taken as x. Again you have to differentiate the term which is assumed as x, that is x square plus a square is differentiation with respect to x is 2x. Is that clear? So here third bracket is closed into, what is integration of x again? This is x square by 2, then what do we write? Dx. Is that clear? Or I is equal to, this is your x square by 2 log within bracket x plus root over x square plus a square. Okay, so here you can cancel, this 2 will be cancelled, minus this half is constant taken outside, integration of 1 upon, this is x plus root over x square plus a square into, within third bracket, what's the LCM? It is root over x square plus a square is the LCM. So numerator will be root over x square plus a square plus 1 into x is x, third bracket closed, into x square by 2, then dx. Okay, 2 is taken outside, isn't it? This half is taken outside here. You don't have to write x square by 2 in this case, because half is already taken outside integral sign. Okay, so here you can cancel this 2 terms, or I is equal to x square by 2 log within bracket x plus root over x square plus a square minus half is constant, integral sign, what is it now? X square divided by root over x square plus a square, then dx. Is it understood now? So we have got this integration, that is minus half integral sign x square upon root over x square plus a square, then dx. So how can you evaluate this integration? So in the numerator, what is the highest power of x? That is 2. And in the denominator within square root, what is the highest power of x? That is also 2. So whatever is there in the denominator within square root, write this expression in the numerator, right? So therefore I is equal to first term is kept as it is, that is x square by 2 log x plus root over, this is your x root over x square plus a square minus half integration of. Now what will you write in the numerator? Within square root there is x square plus a square. Let us write this x square plus a square in the numerator. So this is your x square plus a square. So x square is here, it's okay, it's correct, but a square is not here, you have to cancel it. So what will you write here? Minus a square divided by, in the denominator we have root over x square plus a square. So let us write here root over x square plus a square, then you can write dx. So let us separate this integration now. Or I is equal to, this is x square by 2 log within bracket x plus root over x square plus a square. Let us separate the term, half integral sign. How can we separate it? This is x square plus a square divided by what? Divided by root over x square plus a square, okay? So minus into minus plus, a square is constant, taken outside, minus into minus plus, a square by 2, then integral sign. This is dx divided by root over, this is your x square plus a square. So I think I've understood it. So you can cancel here root over, times root over x square plus a square times. Here you can write dx also, because integral sign and dx are separated. So this is your dx, right? So, or what is I now? This is x square by 2 log within bracket x plus root over x square plus a square minus half integral sign, this is your root over x square plus a square dx, right? Plus a square by 2 integral sign dx divided by root over, this is your x square plus a square. So now for this second integration, this is the standard integral from integration by parts. And this third is also the standard integration, but that standard integration is from the method of substitution. Okay, so we can evaluate this integration again. So or I is equal to, this is your x square by 2 log x plus root over x square plus a square minus half, right? Is that clear? Root over x square plus a square bracket close minus half. Now within third bracket, this is the standard integral from integration by parts. That is the first standard integration. What is the first standard integration now? X root over x square plus a square by 2 plus a square by 2, then log within mod x plus root over x square plus a square, mod sign closed, the base is e, okay? Then close third bracket, then third bracket is closed. I think I've understood it. So what is the integral sign? Root over x square plus a square dx, x root over x square plus a square by 2 plus a square by 2 log within mod x plus root under x square plus a square, mod sign closed, the base is e, then third bracket is closed. Then there is plus, this is the continuation line, plus a square by 2. Now this is integral sign dx divided by root over x square plus a square. That is your standard integral from method of substitution. What is the formula? A square by 2 log within mod x plus root over x square plus a square mod sign close. The base is e. Okay. This standard integral is the fourth standard integral from method of substitution. Then what do you write? Since we have done the integration here, we have finished integration, so you have to write down plus c as a constant of integration. So let us simplify it now. Or I is equal to, first term is kept as it is, x square by 2 log within bracket x plus root over x square plus a square. Let us multiply it. Minus 1/4. Half into half is 1/4. Then x root over, this is your x square plus a square. Is that clear? Minus 1/4 x root under x square plus a square. Minus into plus minus. This is your a square by 4 log within mod x plus root over x square plus a square mod sign close. The base is e. Okay. Then plus a square by 2 log, what do we write? Within mod x plus root over x square plus a square mod sign close. The base is e. Then plus c. Okay. So now again, this third term and fourth term are of similar type, are similar terms. You can simplify it further, right? You can take the LCM and simplify it. So let us simplify it now. So now in the next step, you can write, or I is equal to, the first term is kept as it is, x square by 2 log within bracket x plus root over x square plus a square, then minus 1/4 x root over x square plus a square. Then this third and fourth term are of similar type. You can easily simplify it. So in this case, minus sign is there. Now let's take the LCM. For this 4 and 2, what's the LCM? LCM is 4, right? For this 4 and 2, the LCM is 4. Because these are of similar terms, you can simplify it. So for this 4 and 2, what's the LCM? It is 4. So now the numerator will be a square log within mod x plus root over x square plus a square mod sign close. The base is e. Okay, this is the base e. This is the base e. Okay. Then minus into plus minus. This minus into plus is minus. Now divide this LCM by 2. That is 2 2s are 4. So 2 into a square. 2a square log within mod x plus root over x square plus a square, mod sign close, the base is e, mod sign close, the base is e. Then what do you write? Plus c. Okay, so or I is equal to x square by 2 log within bracket x plus root over x square plus a square bracket closed minus 1/4 x root over x square plus a square. Now this is your a square log within mod x plus root over x square plus a square minus 2a square log within mod x plus root over x square plus a square, base is e. So this is your minus a square, isn't it? Because minus 2a square is more than a square log x plus root over x square plus a square. So it is minus a square. So minus into minus plus. So this will be a square upon 4. This will be minus sign, isn't it? So minus into minus plus. A square by 4, then log within mod x plus root over x square plus a square mod sign close, the base is e, then plus c. So this is the final answer. So I think you have understood it, so you can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 12. So question number 11 is your homework, that is integration of x cubed sin x dx. So you can easily use integration by parts for this problem number 11. So let's do this question number 12. So this is you have to evaluate this integral, that is integration of sine inverse within bracket root over x dx. So let us first write I is equal to integration of, this is sine inverse root over x dx. You don't have to write this bracket, okay? That is sine inverse root over x dx. So this is the only inverse circular function here, but if there is only inverse circular function, you have to use integration by parts. So this is inverse circular function, and there is one, that is x to the power 0, which can be taken as algebraic function. So you can use integration by parts. So there are two functions here. One is inverse circular function, that is I, and the other one is 1 x to the power 0, which is algebraic function, which is a. So among this I and a, which letter comes first in the word let or islet? I comes first. So sine inverse root over x is the first function and 1 is the second function. So let us use integration by parts in this case. So sine inverse root over x is taken outside, integral sine dx minus integration of second bracket d by dx of, this is your sine inverse root over x, integral sine dx second bracket close dx. Is that clear? So it is integrated by parts. Or now let us first integration. Let us do integration first. What is integral sine dx? That is your x. So this is your sine inverse root x minus integration of. So how can you differentiate sine inverse root over x with respect to x? So first of all, you should take it as sine inverse x. What is the differentiation of sine inverse x? 1 upon root over 1 minus x whole square. That is root over x whole square. Into, again you have to differentiate the function which is assumed as x. So what is the differentiation of root over x? It is 1 by 2 root over x into, what is the integral sine dx? That is your x. Then what do you write? Dx. Is that clear? Next, you can cancel it. Root over x, 1s are root over x. Root over x like what times? Root over x. So, or I is equal to, this is your x sine inverse root over x minus, which is constant here, that you can take outside integration, that is your half integration of, this is root over x dx divided by within square root, this is 1 minus x. So I think you have understood it. Or I is equal to, this is x sine inverse root over x minus, this can be written as half within half integration of within square root. Both of these expression are within square root, both numerator and the denominator. So you can write it within whole square root. Whole square root x upon 1 minus x dx. Is that clear now? So let us take it as I1 now. So therefore I is equal to, this is x sine inverse root x minus, let us take it as I1 minus, this is your I1. Okay, so let, now this is I1 is equal to half integration of within square root x upon 1 minus x dx. Okay, so how can you evaluate this integration? Now there is x in the numerator, but it is under square root, and there is 1 minus x, it is also under square root, but it is in the denominator. But you have to consider the expression 1 minus x. Let us do the trigonometric substitution assuming the denominator, that is in the denominator we have root over 1 minus x. So how can you remove square root? So by putting x is equal to sine square theta. If you put x is equal to sine square theta here, it will be 1 minus sine square theta, and its formula is cos square theta. You can easily take the square root of cos square theta, which is equal to cos theta. Okay, so we can put here trigonometric substitution as x is equal to sine square theta. So let us assume x is equal to sine square theta. So in this case we are doing trigonometric substitution method. So now let us differentiate both the sides with respect to theta. Differentiating both the sides with respect to theta. Therefore this is dx by d theta is equal to, this is 2 sine theta, because it is in the form x square. What is the differentiation of x square? 2x. So it is 2 sine theta. Again you have to differentiate sine theta with respect to theta. So what is the differentiation of sine theta with respect to theta? That is your cos theta. Now let us do cross multiplication. Dx is equal to, this is 2 sine theta cos theta, then d theta. Is that understood now? So let us put these values in I1. Therefore I1 is equal to, this is half integration of within square root. What is x? It is sine square theta, divided by 1 minus, what is x again? It is sine square theta, into, what is the value for dx? It is 2 sine theta cos theta d theta. It is 2 sine theta cos theta d theta. So is that understood now? So let us simplify it further. So I1 is equal to half integration of, what is the square root of sine square theta? That is your sine theta divided by, again this is square root of 1 minus sine square theta. So in the denominator also there is square root of 1 minus sine square theta. What is the formula? It is cos theta. So into 2 sine theta cos theta d theta. Clear? So here you can cancel this cos theta, cancel it, or I1 is equal to, this is your half integration of, this is your 2 sine square theta d theta. Now again you can use the formula in this case. 2 sine square theta is there. You can use the formula from multiple angles in trigonometry. What is the formula for 2 sine square theta? You know that it is 1 minus cos 2 theta. Or this is your I1 is equal to half integration of, this is 1 minus cos 2 theta bracket closed d theta. Okay, so now we can separate the term here. Therefore let us separate the term now. I1 is equal to, what is the first integration? It is half integral sine 1 d theta, that is d theta. Half integral sine d theta, half integral sine d theta. Next minus sign is there, minus half integration of, minus half integration of, it is just like multiplication, half integral sine cos 2 theta d theta. It is cos 2 theta d theta. Or I1 is equal to, this is your half into theta minus half into, what is integration of cos 2 theta? This is sine 2 theta divided by 2 plus c. This is just like your cos mx dx. What is integration of cos mx dx? It is sine mx upon m. So here it is sine 2 theta divided by 2. Okay. Or I1 is equal to half into, you can put the value for theta here. If x is equal to sine square theta, what is sine theta? Sine theta is equal to root x. And what is theta is equal to? This is sine inverse root x. Okay. So if there is only theta, you can write it in terms of inverse circular function. That is half, what is theta? It is sine inverse root x minus 1/4 into. Now you can't put the value for theta in this case because it is sine 2 theta. If you put the value for theta here, this is not the simplified form. So let us use the formula of sine 2 theta. What is the formula of sine 2 theta? It is 2 sine theta cos theta then plus c. Here you can cancel 2 and 4, half, right? So, or I1 is equal to, this is your half sine inverse root x minus half into, what is sine theta? From here the value for sine theta is root x. You can write here root x. And what's about cos theta? It is root over 1 minus sine square theta. Let us write cos theta in terms of sine theta so that we can put the value for sine square theta or sine theta. Okay, so what is the formula for cos theta out here? It is root over 1 minus sine square theta. Then you should write plus c. Or now this is I1 is equal to half sine inverse root x minus half root over x into root over 1 minus, what is sine square theta now? Your sine square theta is equal to x. You can write here x, then plus c. Or now this is I1 is equal to half sine inverse root x minus half, now root over x, root over 1 minus x. Both these expressions, x and 1 minus x, are under the square root. So you can write it in the form of within the square root. Within the square root you can write the product of x and 1 minus x. That is, within the square root we have x into 1 minus x. Okay, then you can write plus c. But this is the value for only I1. But we have to find out the value for I. So what is I in this case? So here I is equal to x sine inverse root over x minus I1. So let us put this value of I1 in this I. So therefore, now what is I now? I is equal to, first it is the term x sine inverse root x. Now there is minus sign, minus I1. You have to change the sign. While putting the value of I1 in this I, you have to change the sign, because before I1 there is minus sign. So it is minus half sine inverse root over x, right? So minus into minus plus, you have to change the sign. Don't forget to change the sign here because there is minus sign. So minus into this minus is plus half root over, this is x into 1 minus x. Then what do we write? Plus c. So this is the final answer. So this is the required answer. So this question is also very, very important. Okay, so you can copy it. So this number 11 is your homework. Now we'll do the next problem. So now we'll do the next problem, that is question number 13. Integration of log of within bracket 1 plus x, this 1 plus x whole to the power 1 plus x. Okay, so let us first write I is equal to integration of log of 1 plus x. This 1 plus x power is for only 1 plus x. Okay, so 1 plus x dx. Right. Now, first of all, you have to use the properties of logarithm in this case. You know that if there is log and the power of x is n, log x to the power n, the power n is for only x. So you can take that power in the front of log, that is n log x. Like if there is log x to the power n, then you can write n log x, right? N becomes the coefficient. If the power n is for only x, so this n comes in the front of log. So if there is log x to the power n, then n becomes the coefficient of log x, that is n log x. N becomes the coefficient. Similarly here also, I is equal to integral sign. This 1 plus x is the power of only 1 plus x. So because of this log, you can use the properties of logarithm in this case. This 1 plus x becomes the coefficient. 1 plus x is kept within bracket, then log of this is 1 plus x dx. So I think I have understood it. Okay, so now you can use the integration by parts in this case. So which function is this one? 1 plus x. This is algebraic function a. Which function is this one? Log of 1 plus x. This is logarithmic function, that is L. So among these A and L, which letter comes first in the word liet or ilet? L comes first. So this log of 1 plus x will be the first function and 1 plus x will be the second function. So you can take it outside, log of 1 plus x. This is the first function, or I is equal to log of 1 plus x. It is taken outside, integral sign 1 plus x dx, then comes minus integration of second bracket dy dx of differentiation, that is differentiation of log of 1 plus x with respect to x, then integration of the second function, that is 1 plus x dx, second bracket closed, dx. Understood? So now let us simplify it, or I is equal to, now let us first integrate 1 plus x with respect to x. What is the integration of 1 plus x dx? You can write this 1 plus x as x because the power of x here is 1. So we can take this 1 plus x as x. So what is integration of x dx? It is x square by 2. Similarly here also, this is 1 plus x whole square divided by 2. Actually, this 1 plus x was taken as x and it was differentiated. Okay? 1 plus x is taken as x and it is differentiated, or it is integrated. Not differentiated, but it is integrated. 1 plus x is taken as x, then it is integrated. What is integral sign x dx? It is x square by 2. So instead of x, there is 1 plus x. So it is 1 plus x whole square divided by 2. But the function which is assumed as x is also to be differentiated. So what is the differentiation of 1 plus x? It is 1. Okay. In case of integration, you have to divide it by the differentiation of 1 plus x with respect to x. That is 1. Since it is 1, so it is dividing by 1, 2 into 1. Since it is 1, so you don't have to write that 1 because 2 ones are 2. Okay. Then next, write log of 1 plus x. Then minus integration of, what is dy dx of log of 1 plus x? It is taken as log x. What is the differentiation of log x? 1 upon x, that is 1 upon 1 plus x, into, again differentiate 1 plus x with respect to x, that is your 1, into, again, what is integration of 1 plus x dx? Similarly, it is 1 plus x whole square divided by 2, dividing by, into 1 is also there, you know that, because 1 plus x is taken as x and it is integrated. Again, if you integrate this function 1 plus x whole square by 2 will be 1 plus x whole square by 2. 1 plus x whole square divided by 2. What is the integration of 1 plus x dx? This 1 plus x is taken as x and it is integrated. What is integration of x dx? It is x square by 2. But here it is 1 plus x whole square divided by 2. Again, you have to differentiate the term which is assumed as x. That is 1 plus x is assumed as x. What is this differentiation? What is the differentiation of 1 plus x with respect to x? It is 1. So in case of integration, it is dividing by 1. But in case of differentiation, you have to multiply it by 1. But in case of integration, you have to divide it by 1. So since it is 1, you don't have to write it. Okay. So it is only 1 plus x whole square divided by 2. Then what do we write? Then we write down this dx. Okay. So here you can cancel 1 plus x. 1s are 1 plus x and square will be cancelled. Or I is equal to, this is your 1 plus x whole square divided by 2. Then we can write log of 1 plus x. Okay. Minus this half is constant, it is taken outside, integral sign, now it is 1 plus x dx. Okay, so again you have to integrate 1 plus x dx. Either you can separate it or you can directly integrate it. Okay, similarly as in the previous step, we can integrate 1 plus x with respect to x. So therefore, what is I now? I is equal to, this is 1 plus x whole square divided by 2. Then what do we write? Log of 1 plus x. This is log of 1 plus x. Okay. Minus half into, what is integration of 1 plus x dx? Since the power of x here is 1, 1 plus x can be taken as x to integrate it. So its integration is 1 plus x whole square divided by 2 into 1. You know that. How is it 1? 1 plus x is again differentiated with respect to x, that is 1. So it should be dividing by 1. Okay, so plus c is there. Or what is the final answer? I is equal to 1 plus x whole square divided by 2. This is log of 1 plus x minus, this is 1/4. This is your 1/4 into 1 plus x whole square plus c. So this is the final answer. So I think you have understood it. So you can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 15. You have to evaluate this integration. That is integral of cos inverse within bracket 1 minus x square upon 1 plus x square dx. So how can you evaluate this integration? In this case also you have to do the trigonometric substitution. What should be the trigonometric substitution for x so that we can have here cos inverse cos theta or cos 2 theta? We can put x is equal to tan theta here. If we put x is equal to tan theta, it will be 1 minus tan square theta divided by 1 plus tan square theta. That is your cos 2 theta. And cos inverse cos 2 theta is 2 theta. Is that clear? Similarly, in question number 14 and question number, this is not from the book. I have given you this question. This is also your homework. So these three problems are similar problem. In question number 14 also you put x is equal to tan theta. In this question asterisk marks, this is not from the book, that's why it is taken as asterisk marks. So here also you can put x is equal to tan theta. And the answers for all these three questions will be the same. So I will do this question number 15 here. So you can do this 14 number and asterisk marks at home. Okay, you can do these two problems at home. We will do it here. That is question number 15. We'll do it here. Okay, so let us write here I is equal to integration of cos inverse within bracket 1 minus x square upon 1 plus x square then dx. So in this case you can easily do trigonometric substitution because we have done inverse circular function, isn't it? So how can you simplify it? Cos inverse 1 minus x square upon 1 plus x square by putting x is equal to tan theta. So in this case you can do trigonometric substitution. Let x is equal to tan theta. So let us differentiate it, differentiating both the sides with respect to theta. So therefore dx by d theta is equal to, what is the differentiation of tan theta? You know that it is sec square theta, right? So it is sec square theta. Now let us do cross multiplication. Dx is equal to, this is your sec square theta d theta. Okay, so let us put these values in I. So therefore I is equal to integration of cos inverse within bracket 1 minus, what is x square here? 1 minus tan square theta upon 1 plus tan square theta, right? Into, what is dx here? It is sec square theta d theta. It is sec square theta d theta. Okay. So next, or I is equal to integration of, this is your cos inverse within bracket. The formula for this 1 minus tan square theta upon 1 plus tan square theta is, you know that it is cos 2 theta. This is the formula for cos 2 theta into, this is sec square theta d theta. So I hope you have understood it. So let us simplify it further. Therefore, what is I is equal to now? This is integration of, you know that, what is cos inverse cos 2 theta? It is 2 theta. Then there is sec square theta d theta, isn't it? That is cos inverse cos 2 theta is 2 theta. Then there is sec square theta d theta. So what's about 2? 2 is constant. You can take it outside. 2 integral sine theta sec square theta d theta. 2 is constant, it is taken outside. Now theta, which function is this one? Theta, algebraic function. It is just like your x. Theta is algebraic function and sec square theta is trigonometric function. That is, algebraic function is a and trigonometric function is t. Among these two letters a and t, which letter comes first in the word liet or islet? A comes first, isn't it? That means theta is the first function here and sec square theta is the second function. So let us use by parts in this case. I is equal to 2 within third bracket. Theta comes outside integral sign because theta is the first function. Theta integration of, this is your sec square theta d theta minus integration of second bracket. This is d by d theta of theta. This is integration of sec square theta d theta. Second bracket closed d theta, then third bracket is closed. So this is your integration by parts. Or I is equal to 2 within third bracket theta into, what is integration of sec square theta? That is differentiation of which function is sec square theta? That is your tan theta, right? That is your tan theta minus integration of, what is d by d theta of theta? That is your 1, okay? Again you have to integrate sec square theta d theta, that is tan theta. Then you can write down this d theta. Third bracket is closed. Now multiply by 2, open the brackets. I is equal to 2 theta tan theta minus 2 integral sign tan theta d theta. So I think you have understood it, okay? Or I is equal to, this is your 2 theta tan theta minus 2 into, now what is integration of tan theta d theta? It is log sec theta. Integration of tan theta d theta is equal to what? It is log within mod sec theta plus c, or you may write minus log within mod cos theta plus c. So here let us write log within mod sec theta mod sign closed plus c. Understood? So now, but you have to write down the answer in terms of x, not in terms of theta. So what is the value for theta in this case? So from here theta is equal to tan inverse x, isn't it? Theta is equal to tan inverse x. So or now this is I is equal to 2 into, what is theta here? Tan inverse x into, what is tan theta? It is x minus 2 log within mod. Now you know the value for tan theta. So you can express sec theta in terms of tan theta. So how can you express sec theta in terms of tan theta? You know that sec square theta is equal to 1 plus tan square theta. You have done this formula in class 10. So what is the value for sec theta? It is root over 1 plus tan square theta. It is root over 1 plus tan square theta mod sign close plus c. You can easily put the value of tan theta here now. What is tan theta? It is x. Or I is equal to 2x tan inverse x minus 2 log within mod. So root over means whole to the power half, you know that, isn't it? So within bracket you can write 1 plus, what is tan theta here? Tan theta is x, so it is x square. X square, then you can write whole to the power half. Square root means whole to the power half, and we are putting tan theta is equal to x here. So it is mod sign close plus c. Or I is equal to 2x tan inverse x minus, now because of this log, this power becomes the coefficient, half agadi huncha log agadi. So 2 into half kati bhayo? 2 to cancel bhayeko. That means agadi 1 by 1 we don't write. So 2 into half is 2 gets cancelled. So it is minus log within mod 1 plus x square plus c. So this is the final answer. So this question is also very, very important. Okay, so similarly you can do this question number 14 and that problem. So these two problems are your homework. In this case also you put x is equal to tan theta like this. In this case also you put x is equal to tan theta like this. You will get the same answer for these two questions also. Is that clear? So this much is for today. त आज पनि हामीले जतिवटा प्रब्लम्स गर्यौं यो सबै घरमा रिभिजन गर्नु, जे बुझ्दैन तिमीले मलाई कल गर्न सक्छौ, or you can write down the comment. Okay, so this much is for today. So in the next online class we'll do more problems on this exercise 7. Okay. So you can copy it.